Hello, and welcome to another installment of the video series concerning the book Cold Case North. I'm Megan Gilbert, and I've been just doing some videos concerning the book Cold Case North. So somebody had asked in the comment section in the first video that I had made how exactly uranium is deposited and where it comes from. So I'm going to answer that question for you in this video. So I've actually prepared another PowerPoint. So uranium is actually an incredibly common element on Earth. So an element is essentially a pure substance that would appear on the periodic table, such as gold or oxygen or carbon. Uranium is one of those things. It's designated by the symbol U on the periodic table. It is actually a metal, and it is a very, very common metal on and in Earth. So maybe you're thinking, you know, what do I mean by on and in Earth? Well, when Earth was first forming 4.6 billion years ago, it was essentially just this random molten ball of metal. And as Earth spun and started to take on the characteristics over time and cool of the planet that we know today, essentially it became segregated. So the Earth became segregated due to cooling and spinning and all these other physical factors, meaning literally physics factors. So what we end up having is a crust, which is made up of lighter elements and lighter rocks. So I mean rocks that are mostly made out of silica. So that would be something like quartz. And then as you move, you know, into the mantle and then into the outer and inner core, you progress through more and more metallic elements that you would find in these different layers. So the mantle, for instance, is considerably more metallic, I guess you could say. It has a lot of iron and magnesium and other metals in it, and including uranium. So the mantle would have a consistency kind of like slush. And what makes the mantle hot and what makes us have an outer and inner core that are also, you know, molten is this radioactive decay of uranium into other elements. So as I'm sure all of us know, uranium is radioactive, and it's radioactive meaning that it wants to decay into something more stable. So in the process of decaying into something more stable, it basically gives off radioactivity. And so what it ends up doing is it through a series of reactions and kind of kicking particles off of its little atoms, it deteriorates, I guess you could say, into thorium, and then it undergoes a number of other changes until it eventually becomes lead. And so lead is the end product of uranium's decomposition into something more stable. So maybe kind of, you know, like a lot of things that we would maybe recognize in life, when you're unstable, you want to become something stable. So uranium is no different. It does the same thing. So it's through that process that it releases heat, and it actually causes the mantle to become very, very, very hot. And that's the reason why we have volcanism on the surface. So there's a whole process of why that is the case. And if you want to know more about that, please feel free to ask questions in the comments section. But so there's all this uranium, and it's in the mantle, and it comes to the surface as magma in volcanoes. And so, you know, to take it back to basically the point of why Jim Brady and Abby Halkett were out is because they were looking for granite intrusions, that, you know, billion-year-old granite intrusions that were full of uranium. And there's certain types of magmas that are more likely to produce uranium. And you know, if you want to know more about that, you can also ask in the comments section. But not all magmas will actually end up producing uranium. So it's very specific ones that you need to look for. So that's essentially how you know, their deposits were so these particular deposits that Jim Brady was looking at was created by these earthquake or these volcanoes that had produced magmas that had a lot of uranium in them. But so that's kind of where I'm going to leave that video off for now. I'm going to do a second video where we basically talk about the Athabasca Basin and why it has so much uranium and what exactly is going on with that. So you can look for that video. I'm sure it'll be up this week sometime. So that's my first video, and now we'll do a second video where I actually talk specifically about the Athabasca Basin, because even though you know, that's how these volcanic uranium deposits are formed, that's actually not how the uranium in the Athabasca Basin is formed. It's a completely different different system. So that'll end off this video now because I don't want it to go too long. And we'll start a second video where we talk about specifically the Athabasca Basin. So if you have any questions about any of this, just leave comments in the comment section and I will get back to you. So see you in the next video.